Hello and welcome to this live stream where today I'm going to be looking through paper 1 for the foundation paper for GCSE Maths for OCR. Let me show you the paper here and we can check it out so you can see which one it is. Here we go. This is the paper that we're going to be looking at. I've put a link to the paper in the description. So if you want to look at that later, you can, or if you want to quickly print it out and work along with me, or if you just want to work along with me from the questions on the screen, that's fine. One thing to say is at the end, what I'm going to do is I will go through some more detailed explanation if you want, based on any questions that you have. So if you have a question about something that I'm doing in the video, just stick a comment in the chat, and at the end I will go through that topic a little bit more in detail. Okay, so let me have a look at this and let's get started. Okay, so here we go. This is a non-calculator paper, so we won't be using a calculator, but let's have a quick look at question 1 to start off with. So here we go. We've got question 1 here and it says, write down the mathematical name of the solid shape. Choose from the list. Okay, this is definitely not a cone, it's not a cube, it's not a cuboid, it's not a cylinder, it's not a prism, it is a pyramid, okay? So here we go, we've got to write that down here. Pyramid. Okay, great. Right, next one we've got write down the mathematical name of this polygon. So this polygon, it's got 1, 2, 3, 4, 5 sides. So this is a pentagon. So pentagon. Okay, the next one, we have got part C, and then we'll mark it to check that we've got it correct. We've got, on the grid below, draw a quadrilateral with these properties. All angles are equal, and the diagonals are not at right angles to each other. Oh, the diagonals are not at right, all the angles are equal. Oh, okay, so, I'm struggling to think of what it could be. This isn't a good start. So it's a rhombus, isn't it? All the angles are equal, and the diagonals are not at right angles to each other. But if I draw... Oh, it's a rectangle. Yeah, it's a rectangle, isn't it? 1 second. If I draw a rectangle, let's have a look if that fulfills this criteria. So they're all 90 degrees. Yep, check, check, check. And then let me just quickly look at the diagonals. I'll draw them in now. Here we go. Let's do that in red. So if I draw these in now, we've got a line here. And then we've got a line here. So they're the diagonals. And they definitely do not meet at right angles. So that is all good. Right. Let's have a quick look at the mark scheme to check that these were correct. And then we will move on to the next page. So here we go. Let's get to the questions. Here we go. So what have we got? Pyramid, pentagon, sketch of a rectangle. All good. Okay, brilliant. Right. Let's move on to the next set of questions. Okay, so here we go. What we've got here is round 3,648 to the nearest 100. Okay, so here we go. We're rounding to this 6. So what we're deciding, if we're rounding to the nearest 100, we're going to be deciding, is this closest to 600 or is it closer to 3,700? Okay, so where are we? Now, if I draw a line halfway in between here, the middle point of that would be 3,650. Okay, so 3,648 is less than 3,650. So therefore, to the nearest 100, this is going to be 3,600. Okay. Next one. Round £3.2875 to the nearest penny. Okay, so pennies only take up 2 decimal places. Okay, so we're going to be looking at either 29p or 28p. Okay, and then, well, halfway between that, it's a bit confusing that I did it that way around. Let's write it there. It's 28p or 29p. halfway between 28 and 29 is 28.5. Okay, so if we're looking at this, we've kind of got 28.7, so that lands here. So £3.2875 is going to be closer to £3.29. So that will end up here like this. Right, next part, question 3. What fraction of this shape is shaded? Okay, so we've got 1, 2, 3, 4, 5 parts to the shape. 3 of them are shaded, so it's 3/5. That's what we're going to call that. And then next one here, we've got section B. We've got the diagram is made up of 100 small squares. Shade 3% out of 100. Well, 3% means 3 out of 100. So therefore, we're going to shade 3 of these squares. 1, 2, 3. It doesn't matter how you shade them. That's how we're just going to do that. So let's get the mark scheme out and check that these were all right. So here we go. 3,600. Yep. £3.29. Yep. And 3/5 of a fraction or equivalent. 3 squares shaded. Okay, great. Let's continue. So here we go. Question 4. It says, write down 3 factors of 25. Okay, so we need 3 numbers that multiply. Well, we need 3 numbers that 25 can be divided by. So always with factors, we've got the number 1 and the number itself. So we've got 1 and 25. And then we've got to come up with another number that we can divide 25 by. Well, 25 is divisible by 5 because 5 times 5 equals 25. So here we go. I'm going to put 5 here. Question B. Write down a square number between 40 and 70. Well, okay, so the square numbers are the results of multiplying numbers by themselves. I'll just go through a few. So either side of this, we've got 6 times 6 is 36. We've got 7 times 7 is 49. We've got 8 times 8 is 64. Okay, we've got 2 options here to choose from. So these 2 are both square numbers that are between 40 and 70. I'm going to just go with 49, and that is fine. Okay, right. Let's have a look at question 5. So question 5 says, find the number that is halfway between 4.2 and 6. Well, if you ever want to find the number that's halfway between 2 numbers, you add the numbers together and divide it by 2. Okay, so I'm going to do 4.2 add 6, which is going to give me 10.2. And then 10.2 divided by 2. Well, half of 10 is 5 and half of the 0.2 is 1. So this is going to be 5.1, like this. If you weren't sure about how to halve that, what we could have done was we could have used the bus stop method, okay, and put 10.2 here, and then put our 2 on the outside. So 2's into 1 don't go. Carry the 1 to the 10. 2's into 10, well, 2 times 5 is 10. So that's going to give us the 5. Nothing left over from that one. So now we're looking at 2 into 2. 2 goes into 2 once. So here we go. 5.1. And let's have a quick scroll up of those answers again, and then we will mark these off. Okay, so here we go. 1, 5 and 25, perfect. 49 or 64, great. 5.1, spot on. Okay, so let's now look at the next set of questions. So here we go, question 6. We've got 4 lines meet around a point. Work out the size of angle A. Okay, so what we're expected to know here is that this angle, this square, if you see this square, that is 90 degrees. And we're also expected to know that angles around a point, think if you can think about it at the moment, equal 360 degrees. Okay, so here we are. So what we've got to do is we've got to find out what angle A is to make all of these add up to 360. And we don't have a calculator. Okay, so this is really just testing our addition skills. So I'm going to use the column method here. So I'm going to do 125, add 39, add 90. Okay, and then once I've got this answer, I'm going to see what we've got to add on to get up to 360. Okay, so we've got 5 add 9 is 14. Okay, add 0 leaves it as 14, so carry the 1. 2 add 3 is 5. 5 add 9 is 14. Add the 1 is 15. And so carry the 1 again. 1 add 1 is 2, so I'll put the 2 here. So these make 254. And now we've got to do 360, take away 254. Okay, well, 0 take away 4 we can't do. So I've got to borrow 1 from here and turn this 60 into like a 50 and a 10. 10 take away 4 is 6. 5 take away 5 is 0. 3 take away 1 is 1. So here we go, we've got 106 degrees. Okay, here we go. 106 degrees. Right, let's now look at this question 7 here. And here we go, let's have a look. It says, a painter mixes red paint and yellow paint in the ratio 2:3. They make a total of 1.5 litres of paint. Work out how much red paint they use. Give your answer in millilitres. Okay, so what we've got here is if we've got 2:3 red to yellow, that means that 2/5 of the paint is red. Okay, because we've got 2 parts here, 3 parts here. So we know that 2/5 will be red and 3/5 will be yellow. Now we've got 1.5 litres of paint, 1.5 litres here. And they want us to give our answer in millilitres. So what I'm going to do first of all is I'm going to turn the litres into millilitres. So 1 litre equals 1,000 millilitres. So 1.5 litres is this times 1.5, or in other words, this and then half of that again. So we've got 1,000 times 1.5, so that'll be 1,500 millilitres. Okay, so now I need 2/5 of 1,500. Well, 1/5 will be given by 1,500 divided by 5. So to do this, I'll use the bus stop method. So here we go, 1,500 divided by 5. So 5s into 1 don't go. So we then look at 5s into 15. 5s into 15 go 3 times with no remainder. So here we go. 5 doesn't go into 0, 5 doesn't go into 0. So we got 300. So 1/5 of the paint is 300 millilitres. We want 2/5 of the paint, which means we want that 1/5 twice, okay? So if 1/5 equals 300 millilitres, okay, 2/5 will be 2 lots of this. So times that by 2, times this by 2, and that will be 600 millilitres. So I'll write this down here, 600 millilitres. Right, so 2/5 is 600 millilitres. Right, let's have a look here at this next one. And this says, one second, let's mark these. They're a bit harder that time. I might have actually made a mistake. Let's quickly check. So 106, no, we got that. And 600, we got that as well. Okay, so well done. If you got those two, let's move on to the next question. So here we go. A little bit trickier this time. We've got a shape involved. This says the diagram shows a cuboid with dimensions 12 centimeters by 5 centimeters by X centimeters. The volume of the cuboid is 240 centimeters cubed. Find the value of X. Okay, so the volume of a cuboid equals length times width times height. Okay, so let's put in the information that we have. So we know that 240 equals, 12 times 5 times X. Okay, so now we know that 240 equals, well, 12 times 5 is 60. So 60x. So now we've got to think, what number multiplied by 60 gives us 240? Well, I know that 6 times 4 equals 24. So therefore, 60 times 4 will give us 240. So the answer to this one is x equals 4. Okay, so here we go. X equals 4. And you could have thought about doing this by, if we rewrite that as 60x equals 240, divide by 60, and that gives us x equals 240. Oh, no, it doesn't. Sorry, it gives x equals 4. Sorry, that's what I wrote. I don't know. This is the problem. Sometimes with maths, you can do everything right and you write down the wrong thing. Okay, here we go. Right, x equals 4. Right, let's have a look at question 9. So here we go. We've got Heidi and Yoshi compete in the same race. Heidi competes the race in 6 hours. Heidi's average speed was 50 miles per hour. Yoshi's average speed was 48 miles per hour. Calculate how long it took Yoshi to complete the race. Okay, right, so let's break this down. So we know that Heidi's average speed was 50 miles per hour. So that means in 1 hour, Heidi travels 50 miles. Here we go. So in 1 hour, Heidi travels 50 miles. Now, we know that Heidi completes the race in 6 hours. So here we go, we want 6 hours here. So we know that 6 hours is 6 lots of 1 hour. Now, if in each hour she does 50 miles, we need 6 lots of 50 miles in order to find out how far she's travelled. Well, 6 times 5 is 30, and then if we add on the 0, we get 300. So here we go. So 50 times 6 will be 300 miles. So we now know that the race was 300 miles. Now Yoshi's average speed was 48 miles per hour. So in 1 hour, Yoshi travels 48 miles. Hello. So in 1 hour, Yoshi travels 48 miles. So what we have to think about is how many hours would it take them to get to 300? So in other words, we're looking for 48 times what equals 300. Right, okay. How do we do this? Right, this is a tricky one. So what we can do is, well, basically what we're looking at is if we divide both of these by 48, what we're looking at is this mystery thing. The number of hours will be 300 divided by 48. So what I'm going to do here is I'm just going to simplify this into smaller chunks until it's something we might be able to divide. So first of all, I'm going to half both these numbers. So actually, I'm not going to half both of these numbers. I can see that both of these things can be divisible by 3 because 300, well, divided by 3 is 100. And 48, well, the tip for finding out if any number is divisible by 3 is if you add up the two numbers and they give you something that's in the 3 times table, then that number is divisible by 3. Okay, so what I'm going to first of all do, I'm going to divide both of these things by 3 to make this an easier calculation. So 48 divided by 3, I'm just going to quickly lay it out over here. 3's into 4 go once, remainder 1, 3's into 18 go 6. Okay, so this fraction becomes 100 over 16. Okay, right, and then we can simplify that again. We can get that into 50 over 8. We can get that as 25 over 4. And what I'm going to do now is I'm going to write this as hours and minutes, okay? So 25 over 4 gives us 6 hours and a quarter. Okay, sorry if that's a bit of a jump. The reason why that is because if we think about 4's into 25, well, 4, 8, 12, 16, 20, 24. So 4 times 6 makes 24, and then we've got 1 left, which is where this quarters come from. So this is 6¼ hours. So 6¼ hours, well, I know that a quarter of an hour is 15 minutes, okay? So this is 6 hours and 15 minutes for Yoshi to complete the race. Okay, right, let's get these 2 questions marked to see if that was correct. So the first one was 4 centimetres, which we got correct. And the second one is 6 hours and 15 minutes. So that was correct as well. Great. Okay, right, let's have a look at the next question. So here we go. We've got this question here, question 10. And this question says that Alex and Emma use this recipe to make scones. The recipe shows the ingredients needed to make 16 scones. Ingredients to make 16 scones. Okay, and then we've got the ingredients there. The question bit asks, Alex makes 24 scones. He uses a tablespoon to measure the amount of milk he needs. The size of the tablespoon is 15 ml. How many tablespoons of milk should Alex use to make 24 scones? Okay, right, so the trick here with this question is to see that this is 16 scones. Well, half of 16 is 8, okay? So we can easily get the recipe for 8 scones. And then, once we have the recipe for 8 scones, we can add the ingredients required for 16 scones to the ingredients required for 8 scones, and that will give us the ingredients required for 24, because 16 add 8 equals 24. So let's have a look at how this is going to work. So if we've got 16 scones here, we're going to look at 8 scones next to it. Oh, that's 18. Sorry about that. We want 8 scones next to it. Okay, so actually we only really care about the milk because that's all they're asking for. So we need to find out half of 70. Well, half of 70 is 35. Okay, so for the 16 scones, we need 70 ml. For the 8 scones, we need 35 ml. So we need to add these 2 things together. So we've got 70 add 35. Well, 70 add 30 is 100. And then add the 5. That will be 105 ml of milk that we need. So we want 105 ml. And then we need to work out how many tablespoons is that. So how many 15 ml tablespoons gets us up to that 105. So what we can do is we can kind of just count up in 15. So 15, 30, 45, 60, 75, 90, 105. So that's 1, 2, 3, 4, 5, 6, 7. Here we go. So that's 7 spoons. Right, let's have a look at part B. And part B says, Emma has 1 kilogram of flour and 240 grams of sultanas. She has lots of all of the other ingredients. Work out the maximum number of scones that Emma can make. You must show you're working out. So Emma's going to be limited by her flour or her sultanas. Okay, so let's have a look at this. So flour, we've got 400 grams for 16 scones. Okay, so she's got 1 kilogram of flour. So let's think about that. So 400 gives us 16 scones. She's got another 400 left, which will give us another 16. And then if she's got a kilogram, that means 1,000 grams. So currently we're up to 800. So 200 grams are left. So 200 grams are going to give her another 8 scones, okay? So all in all, she can make this many scones with her flour. So we've got 16 add 16 is 32. Well, let's do it the column method. 6 add 6 is 12. Add 8 is 20. So I'll put a 0 here, carry a 2. 1 add 1 is 2. Add the 2. 40. Okay, so with the flour, she's going to be able to make 40 scones. Now let's have a look at the sultanas. So 240 grams of sultanas. So she needs 80 grams of sultanas for each thing. So let's see how many lots of sultanas she's got. So 80 grams gives 16. Okay, another 80 grams. Well, I'm going to count up here. So 160 grams would take us to 32. And then let's add on the other 80 grams here. So that's 240 grams, which is how much she has, would take us to 48 scones. Okay, so there we go. We've got the flour allows her to make 40 scones, and the sultanas allow her to make 48. So the limiting thing, the maximum number she can make, is going to be 40. Okay, I'll be right back. Okay, right, let's have a look at those answers. So we had 7 and 40 there. So here we go. Yeah, 7's correct, and 40 is correct as well. Wonderful. Right, let's have a look at the next couple of questions. So here we go. Question 11 says 140 people are asked if they have a bicycle, B, or a car, C. 22 people have a bicycle, 72 people only have a car. 29 people have both a bicycle and a car. A, show this information on the Venn diagram. Okay, so let's do the people first that have both, because that's the easy one. That's going to go in the middle. Hello, thank you for joining. Right, so, yeah. Right, okay, so 29 people have a bicycle and a car, which is going to go in the middle here, and we are going to have 29. So next bit we're going to have here is we need to work out how many bikes are left. Well, 22 people only have a bicycle. Oh, this is nice and easy. So that means just 22 people go here. 29 people, 72 people only have a car. So that's going to go here as well. Right. So there we go. We filled out the Venn diagram. Now let's see what else we can do. Okay. Part B says, how many people do not have a bicycle or a car? Right. So that's going to be, there's 140 people in total. And that's going to be 140. Take away these three things added together. Okay. So we need to work out this 22 and 29 at 72. So again, I'm going to do the column method for this. Just here. And write these down. So 2 add 9 is 11. And 11 add 2 is 13. So I'll put a 3 here and a 1 here. And then I'll do this next line. So this next column even. So next we have 2 add 2 is 4. Add 7 is 11. Add 1 is 12. So here we go. So this group of people make up for 123 people. So what we're looking for is we're looking for 140 minus 123, and that will give us 17. Okay, so there should be 7 people who do not have a bicycle or a car. Part 2 says, write your answer in the correct place to complete the Venn diagram. So this is going to go here. Okay, so, yeah, I think, sorry, this is a live lesson, so I'm just going to answer a question that I've got. If you've got your November reset, I think one of the best things that you can do is watch videos like this and make notes. And another thing that you can do is you can go through things topic by topic. So if you've got, which is, I'm going to plug someone else's website here, Because right now at this stage, if you're about to do your exam, I would say possibly the best thing that you could do would actually be to do something like go on Save My Exams and look through the topics that you might not be most happy with and and go through, maybe watch a video somewhere on how to do them. You can actually, I've got quite a lot of videos at crackmaths.co.uk if you want to check my videos out. And they've been quite nicely put together with questions and stuff. But for the true exam style questions that you're going to be looking for as well, I would suggest maybe look at the topic. In fact, yes, I'm going to plug my own website. So go to crackmaths.co.uk. There's a list of, I've written down all the topics that are there for the foundation GCSE, and have a look at them. If you're happy with them, that's great. If you're not happy, watch a tutorial. But once you've done that, the best thing that you could do is probably to get a lot of practice on a topic is to go to Save My Exams and look up the topic that you want to work out, and then they've got it really nicely laid out actually. They've split them into like easy, medium and hard. And what you can do is you can just kind of like work through them, because the main thing that's going to help you with your GCSE at this stage is making sure that you've got topics that you're really confident on. The exam papers are wonderful and you should do as many exam papers as possible. But what you're going to find is if you've got the topics that you're really happy with secure, then that's what's going to get you the marks, okay? It's better to understand a few things really, really, really well than to continuously go through everything if you don't understand it. So that would be my advice as a teacher anyway, is to look at some of these topics on the exam papers, look at the ones that you know you've got that are in your capability of understanding, visit something like crackmaths.co.uk, look at the tutorials on how to improve those skills, and then if you need some more help, if you want to then really hone in on the practice on those to make sure that you can really secure the points for those questions, I would then go to something like Save My Exams and make sure that you visit all of the past paper questions that you can on the topics that you think you're going to be able to achieve. Yes. Okay, right. If that's okay. Does that make sense? I hope it does. Anyway, I'm waffling now. I'm going to continue with the question. Yes, right. So, question part C. One of the 140 people is chosen at random. What is the probability that they have a car? So, there's 140 people altogether. And how many of them have a car? Well, there's these 72 people that have a car, and there's these 29 people as well. So we've got the 29 people here that have a car, the 72 people here that have a car. So we need to work out 72 add 29, and that will be what goes on the top of our fraction. So 72 add 29 is going to equal 72 add 29. 2 add 9 is 1. And 7, 2 add 9 isn't 1. 2 add 9 is 11. 7 add 2 is 9. Add 1 makes us 10. So here we go. It's 101 people out of 140. So that is our probability over like this. Here we go. So, right. Next, so let's check the answers to this. And here we go. Yeah, that was what our Venn diagram looked like. 17 is what I got. And 101 out of 40 is the probability. Okay, perfect. Right, we're doing all right here. Let's keep going. So question 12, what we've got here is we've got the costs to hire a motorhome are shown below. So the first day is £130. The second, each extra day is £90. And each mile travelled costs 60 pence. Finley hired a motorhome and travelled 560 miles. The total cost of hiring the motorhome was £916. Calculate how many days Finley hired the motorhome for. You must show your working out. Okay, right, so let's do what we can. So Finley hired the motorhome and travelled 560 miles. and the cost was this. So let's work out the cost for 560 miles. So we've got 560 times 60, okay? And I'll put that down here, times 60. Okay, so I'm actually going to use, I like this method here for long multiplication. This is my chosen one. 560 times 60. Okay, and then what we do is we fill out these bits here. So 0 times 6 is going to be 0, 0. 6 times 6 is 36. 6 times 5 is 30. 0 times 0 is 0, 0. 0 times... Oh, all of these are going to be 0. That's nice. Now what I can do is I can add these up. So I've got 0 here, 0 here, 6 here, 3 here, and 3 here. So 560 times 60 gives us 33,600. Okay, right. So that is pence. So that means that that is going to be, divide that by 100, turn it into pounds. That's going to be £336 on mileage. Okay, right. So £336 has been spent on mileage. Okay, so let's take that away from our total. So 916, take away the 336. It's going to be 0 here. We'll have to borrow from there. 8, 1. 11 take away 3 is 8. 8 take away 3 is 5. So there's going to be £580 left that has been on hire. So now what we need to do is we can take away the first day. So 580, oh, 1 second. So £580 here. Take away the first day, which costs £130. Is that right? Yeah, take away the first day, which costs 130. Leaves us of 0, 5, 4. So we had 1 day plus the rest of the days, okay? And the rest of the days cost, so for the rest of them, we know that 1 day equals £90, but we spent £450. Well, I can see that 90 times 5 equals 450. So that's that times 5. So that was 5 days. So we had the 1 day for the start and then 5 days extra. So that means that they hired the car for 6 days altogether. Okay, let's just check. Calculate how many days Finley hired the motorhome for. You must show you're working out. So that will be 6 days all in all. Okay, so let's check that on the mark scheme and then move on. So here we go. 6 with the correct working. Okay, great. So let's move on here to the next section. Oh, here we go. Right, question 13. Right, so question 13 says, oh, one sec. Sorry about that, 1 second. Right, so question 13 says, a climber is in a competition. Here are the scores after 2 events. So we've got event 1, they scored 24 out of 30 points. Event 2, they scored 32 out of 38 points. And event 3, we do not know their score. Yes, we do. Oh no, we don't know their score, but we do know it was out of 52 points. The climber's overall score is found by adding the 3 scores together. Find the score the climber needs in Find the score the climber needs in event 3 to achieve 85% of the total points. Right, okay, right. So what we need to do is we need to find out how many total points were available. And then from there, what we need to do is we need to work out what 85% of that is. And then from that, we need to find out how many points we need to get up to 85%. Okay, so let's have a look at this. So first of all, let's add up these points here. So 30, add 38, add 52. Okay, so 0 add 8 is 8, add 2 is 10. So 0 here, 1 here. 3 add 3 is 6, add 5 is... add 5 is 11, add 1 more is 12. So here we go. So 120 points total is what is available. Okay, so now what we need to do is we need to find 85% of that. So 85% of these 120 points. So let's just say we know that 100% is the 120 points. We can then go to 10%, which would be 12 points. We know that 5% is half of 10%, so that would be 6 points. Okay, now what I'm going to do here is I'm going to add the 10 and the 5 together to get 15%. So 15% is 18 points. Okay. Now I know that 100% take away 15% leaves us with 85%. So 100% take away 15% equals 85%. So I'm going to do 120 points, take away the 18 points, and that will leave us with 102 points. So we know that they need to get 102 points altogether. So far we've got 24, add 32. Well, 4 add 2 is 6. 5, so currently they've got 56 points altogether. And they need 102 points. So what I need to do now is I need to do 102 take away 56. Okay, so let's have a look at this. We've got 2 take away 6. Well, 2 take away 6 doesn't work. So we've got to borrow from the 0. We can't borrow from the 0. So we treat this as a 10. We borrow from the 10. This becomes a 9. And then that becomes a 1. So 12 take away 6 is 6. 9 take away 5 is 4. Okay, so they're going to need to get 46 points in order to get the score that they want. So here we go. I'll write that down here. 46 points. And let's have a look at if that was correct. Okay, so here we go. Yep, 46 points. Perfect. Okay, so back to this. Let's have a look at the next question here. Okay, so question 14. It says, for each graph below, select its possible equation from the list. Okay, right, so let's have a look. So y equals x, this is the graph of y equals x, this one here. I'll write it there, y equals x. Okay, it's called y equals x because everywhere on this graph, the y value is the same as the x value. Okay, so you can kind of see it here. At 0, 0, they both there. Now, if in theory, if the scales are the same, if I had a 1 here, that would be a 1 here. If I had a -2 here, so that would also be -2. So that's why that is y equals x. This shape graph here, if you see something like this, this is always a cubic. Okay, so it will either look like this, if it's the positive cubic, which it is in this case, y equals x cubed. Or if it's the negative cubic, it would look like this here. Woo. That would be a negative cubic. So that would be y equals -x cubed. But this one here is the positive cubic because it's kind of generally going in the upwards direction. Okay, right. The next one here, let's have a look. Oh, there's only 2 of them. That's great. Okay. So let's just confirm that with the answers. So here we go. B and F. Yep, that is correct. That is what I put. Okay, let's continue on. So that's there. Is there anything else on this page? No. Okay, right. Question 12. Here are 2 function machines. Well, 2 functions. Function A. Function A has an input of times 5 plus 4. And that's what has an input, and then we times the input by 5 and add 4. That gives us the output. Function B, we times it by p, and then we take away 8. When the input for each function is 6, the output for function A is equal to the output for function B. Work out the value of P in function B. Okay, so let's put these values in. So 6, we've got 6, and then we're going to times it by 5. Okay, we're doing that first, and then we're adding on 4. Okay, so 6 times 5 is 30, and then add 4 gives us 34. So there we go, we've got what this is, 34. It says when the input of the function is 6, the output of function A is equal to the output of function B. Okay, right. So now let's look at this function B here. We'll put the 6 in. So we get 6 times P. Here we go. And then take away 8. And then that equals 34. Okay, so let's first of all think about what number take away 8 equals 34. Well, the way we can do that is by doing 34 add 8. So 34 add 8 gets us to 42. So we know that 42 take away 8 equals 34. Therefore, 6 times P has to equal 42. Now, if 6 times P equals 42, what I've got to think about is what number multiplied by 6 equals 42. Well, I know from my times tables that 6 times 7 is 42. So P has to equal 7. No, it's definitely paper 1 that's a non-calculator paper. Yeah, definitely paper 1. Here we go. Yeah, one sec. I can go back to the start just to quickly double check for you, but here we go. Just to show you. Here we go. Paper 1 foundation tier. Oh, right. Yeah, no, you're right. Okay, sorry about that. Oh my gosh, I was thinking that some of these calculations were pretty hard. You can use... that's so funny. Sorry, so I don't often do OCR. I've only just done it because I wanted to get a collection of different past papers on my website. But yeah, most papers with Edexcel and AQA, their first paper is the non-calculator one. So paper 1 is normally the non-calculator one. But thank you for pulling that up. That's really useful, actually. Thank you. Yeah, that's quite embarrassing. But never mind. Thank you for letting me know. I'll bring up my calculator. There's no point as struggling without having the calculator. So here we go. There's my calculator on the screen now. And I will use this for the remainder. And I will put a note at the start to apologise. But yeah. You learn something new every day. Okay. Right. So let me go back to the page that we were at. So here we go. That's going to be really useful. I can see some of the questions that are coming up, and they would be pretty tricky without a calculator. So here we go. So we've got that one there. So if you had your calculator and you wanted to do that, you could have done in order to find out that it was 7. You could have done 42 divided by 6, like so, and that would give you 7. Okay, right. Let's have a look at question 16a. So here we go. Multiply out. Oh, 1 second. Let's just quickly mark that last one just to check that that was all okay. So did I get 7? Yes, I did. I did get 7. Okay, wonderful. Right, here we go. Multiply out 5a bracket 2 minus a. Okay, so what this is going to do is this will be 2 lots of 5a, which will be 10a. Because I've done this bit times this. And then I've got 5 times 5a times negative a. And that's going to be minus 5a squared. Okay, so I'll put that down here. So we've got here minus 5a squared. Oh no, well, I've got to write the whole thing. So here we go. 10a minus 5a squared. Right, let's have a look at part B. So part B says solve 5x plus 9 is greater than 12. So what we've got here is, well, we've got to find out what 5x must be. So if 5x plus 9 is greater than 12, 5x has to be greater than 3, okay? So, and we could do that. We can say we've taken away the 9 from both sides. So we get 5x is greater than 3. And then, because, well, actually, 5x has to be greater than 3, because if it's less than 3, it won't make a value that is greater than 12. So if 5x is greater than 3, we then need to find out what x is. So we divide both sides by 5 in order to be left with 1x. So we get x is, well, 3 divided by 5, which we can write as 3/5. Or, now that I know I've got my trusty calculator, I can simply do 3 divided by 5 on here. So here we go, 3 divided by 5, and get 0.6, okay? So here we go, let's write that final inequality down there. X is greater than 0.6. Right, part C. Solve by factorising. Okay, right, so this is where we put, because this, well, just check, there's several different types of factorising, but because this is a 3-part quadratic, so an x squared plus a something x plus a regular number, this goes into double brackets like this. The only way we can get an x squared is by doing x times x. Now, there's multiple ways of getting 12. To get a 12, we can do 1 times 12, we can do 2 times 6, and we can do 3 times 4. Now, the way that we decide which two numbers it is that these two numbers have to add up to 7, okay? Because this is 7x. So I can see that 3 add 4 is 7, so it's going to be here. So we're going to have 1 is add 3, and 1 is add 4, okay? So that's that factorised. Now that we've done that, we've got x plus 3, bracket x plus 4, equals 0. Now remember, these two brackets are being multiplied together, so this is basically just something times something equals 0. Now the only way you can make 0 by multiplying two things together is if one of them equals 0. So either x plus 3 equals 0, or x plus 4 equals 0. Now, if x plus 3 equals 0, x has to be negative 3, because minus 3 plus 3 equals 0. If x plus 4 equals 0, x has to equal minus 4, because minus 4 plus 4 equals 0. So they are our two solutions. So we've got x is minus 3, and x is minus 4. Okay, right, let's mark those questions. So here we go, we've got excellent, 10a minus 5a squared, x is greater than 0.6 or 3/5, both are the same. And then we've got minus 3 and minus 4 there, so perfect. They were all correct. Right, and then we can move on. Right, question 17. This says a prime number is a whole number that has exactly 2 factors. Explain why one is not a prime number, because it only has one factor. Here we go. So that's number what? 17a. And then part B, we've got a and b are prime numbers. Write down the 6 factors of a squared times b. Oh, right. Right, well, if a and b are prime factors, well, first of all, the number itself and 1 is always a factor. So a squared plus b will have a value, okay? And a squared plus b will be divisible by a squared plus b. So a squared times b is the first factor, and 1 is the second factor. The other factors we're going to get out of this is we can divide this by a squared, we can divide it by a, we can divide it by b, and we can divide it by ab. Okay, that's a weird question, but these are all the factors of a squared b. Okay, right, let's mark that to check that that's correct. So here we go. 1ab, ab, a squared b. Perfect. Right, let's have a look at the next question. Question 18. Okay, the table shows the results for a sports club A team. So here we go. We've got they won 18, they drew 10, they lost 12, and total 40. Complete a labelled pie chart to show the results, to show these results. Okay, right. So let's have a look at that. So the thing about a pie chart is basically we're dividing each of these into 360 degrees. So we know that the whole section here is 360 degrees. So what we need to do is we need to get these fractions. We need to think of each of these as fractions. So this is 18 40ths. This is 10 40ths. And this is 12 40ths. We can think about these fractions of the pie chart or these fractions of the win out of 360 degrees. So we have to times each one of these by 360. Okay? Now that's one way of doing it. Or the other way of doing it is to think about what times 40 gets us to 360. Well, that would be times 9. So if we multiply each of these by 9, that will get us the degrees as well. So what I'm going to do is I'm just going to get the calculator out now that I know that I've got it. And we can work these out here. So here we go. So first of all, let's just do this first one here. So 18 out of 40. So 18 divided by 40. Here we go, 0.45. And then we want that out of 360. Here we go. And that is 162. Now, I don't have a protractor here, so I'm just going to estimate these angles. Okay, but 162 will be around here. I'll just label it 162 degrees, and that's win. Okay, then we've got 10 out of 40. Okay, so 10 divided by 40 equals 0.25 times 360 gives us 90 degrees. So that's a right angle. I'm actually going to use, just because I don't have my protractor, I'm just going to go here and label that with that square. So this is draw. Oh, right, and the rest is lose. Okay, there we go. So that angle will be naturally correct, but let's write it down so that they can see that we've worked them all out. So there might be points for that. So 12 divided by 40 equals this, times 360 is 108. So there we go, 108 degrees, 108 degrees. Okay, there we go. Right, let's check that is all right, and then we can mark that. So here we go, correct pie chart, 160, 90, and 108. Perfect. Right, so here we go. Let's go on to part B. Oh, where's part B? It must be down below. Oh, here we go, right. Here are the results for a sports club's B team and C team. B team, win, draw, lose. C team, win, draw, lose. The C team manager says the pie chart shows that the C team won more games than the B team. Referring to the pie chart, explain why the C team manager may not be correct. He's not correct because we don't know the total number of games played. There we go. And let's just check with the mark scheme for that. And it will say here, the pie chart does not show how many matches were played by each team. Perfect. Right. Let's move on to question 19. Okay, right. So I'm just going to have to shrink this a little bit. Sorry if this is going to be a bit small. This question here says, the graph shows Taylor's journey from home to an airport. During the journey, Taylor stops for petrol. How long did Taylor stop for? Okay, so this shows the distance. So as long as the distance is increasing, she is moving. Now, this is the only section here where the distance isn't increasing. So this is the bit that she's stopped. She's stopped for 2 squares Now I can see that 1, 2, 3, 4, 5 squares. I'll just write that up here. 5 squares equals 10 minutes. So that means that 1 square equals 2 minutes. So if she's stopped for 2 squares, that means she's stopped for 2 minutes here, 2 minutes here. So she has stopped for 4 minutes in total. Okay, right. Part B says, Taylor drives the same route back home from the airport at an average speed of 45 kilometers per hour. Taylor leaves the airport at 10 o'clock. What time does Taylor arrive home? Right. So, 1 second. So she's gone to the airport. Is this what's happened? How far away is the airport from her home? So the airport is here. Again, we've got the same scale on the sides here. So we've got 1, 2, 3, 4, 5. We've got 5 squares here. So each of these squares is worth 2. So that's 42, 44, 46, 48. 48 kilometers. Okay, so she's got to travel 48 kilometers. Okay, she travels at 45 kilometers per hour. So 1 second, let's work this out. So we've got 1 hour equals 45 kilometers. Okay, but we want to travel 48 kilometers. So this is annoying. So it's just a little bit more than an hour. So we've got to work out what we're timesing this by to get this. So what is that? So we need to know 45 times what gets us to 48. 45 times something equals 48. So 1 second, let me just put this over here. 45 times something equals 48. So we do 48 divided by 45. Okay, 48 divided by 45 will tell us what that is. 48 divided by 45 equals 1.0666 recurring. Okay, so it's 1 hour, 0.066 recurring minutes, well 0.06666, but this is decimal time. Okay, so this is currently decimal time. So the decimal time is 1.066666 hours. So we know that is 1 hour, and then we need to convert the decimal part into minutes. Okay, so we're going to take away the 1. Okay, so this is so the part of the hour that she's got is 0.06666 of an hour. So of an hour means of 60 minutes. So of that, so we're going to times this by 60 to give us 4. Okay, so that's 1 hour, 4 minutes here. Okay, right. Let me remove that here, and then let's mark that just to check that they're correct. Oh, oh no, I didn't finish the question. Right, 1 second. So 1 hour, 4 minutes. She leaves at 12. What time does she arrive back? So 1 second, let me get rid of that. So it's 1 hour, 4 minutes. So we want 22 plus 1 hour, 4. So that's going to be 23 hours and 4 minutes altogether. Okay, which I have just seen is correct on the mark scheme. So here we go. There we go. 4 for the first part, 11 and 04 for the second. Right. Let's move on. So here we go. 1 sec. Sorry about this. I'll leave you with these questions. I'm just going to go fill up my water bottle, but I'll be right back. Right, okay. Let's have a look at these questions here. And this one says, write an expression for the weight of an object weighing X kilograms. Okay, so that is going to be the weight of an object weighing X kilograms in grams. Sorry. Write an expression for the weight in grams of an object weighing X kilograms. Okay, so let's see. 1 kilogram, 1 kg equals 1,000 grams. Okay, so X kg, okay, would be times X. So we'd have to times this by X. So that would be 1,000 X grams. Okay, so here we go. The weight, write an expression for the weight of an object in kilograms, so it'd be 1,000 X, because we've times the 1,000 by X. Write an expression for the area in meters squared of a garden area that is Y centimeters squared. Oh my gosh. Right, so let's have a think about this. So if I've got, let me just explain this one, because this one isn't one that people remember. So we know that 100 centimeters equals 1 meter. Okay. Now, if we want to find, if we imagine we've got a square and we've got two squares here, and this one is 100 centimeters, 100 cm, and this one here is 1 meter. They're both the same size. If we were working out the area of these things, I hope so too. If I try to find the area of these things, this would become 100. The area of this would be 100 centimeters. Well, 100 times 100. So let's just get out the calculator for that, because we've got it. So we've got here 100 times 100 equals 10,000. So 10,000 centimeters squared equals 1 meter squared. Okay, right, so let's remove that then. So write an expression for an area in meters squared with an area of Y centimeters squared. Okay, so what have we, how, this is mean for 1 mark. So we now know that 1 meter squared equals 10,000 centimeters squared. Okay, so what we then need to do is we need to write meters squared in terms of centimeters squared. So no, we don't need to write centimeters squared in terms of meters squared. So essentially, we want to find out what 1 centimeter squared is in terms of meters. Okay, so here we go. So we know that 1 centimeter squared, well, what we're going to have to do is we're going to have to divide 1 by 10,000. So 1 divided by 10,000. Because we had 10,000 centimeters squared and we only want 1. So here we go. So 1 centimeter squared equals 0.0001 meters squared. And so there we go. We want Y centimeters squared now. So Y centimeters squared will be this times by Y. So it'll be 0.000 Y meters squared. So here we go. 0.00. Actually, I'll put this here. Actually, 0.001 Y meters squared. There we go. That is better, a better way of writing it. So both of them would be correct, but I prefer this method, this one here. Okay, right. Question 21. Oh, sorry, I had left the calculator on the screen. So 0.001 Y meters squared. Right. 21. A student uses trigonometry to work out an angle B in a right angled triangle. They tell the teacher that sine B equals 5/4. Explain why this must be wrong. Well, this is going to be wrong because the sine alpha or sine B equals opposite over hypotenuse, and the hypotenuse is always the longest side of the triangle. Okay, so there we go. Right, now, let's have a look at this one here. So here is a right angle triangle. Work out the value of x. Okay, so this is the angle that we have. So this is the height. This is the adjacent. So if we've got the adjacent, if we think about SOHCAHTOA, we want to use this one here because we've got the adjacent and the hypotenuse. So that tells us that cos x equals the adjacent, which is 24 over 40. And then in order to find out what x is, we've got to get cos to the minus 1 of both sides. So cos to the minus 1 of, well, we do cos to the minus 1 of 24 over 40 and find out what this is. So let me just get out the calculator and we can calculate that there. So let's switch to scientific. Okay, cos to the minus 1. So I need the second function here. Well, let's just clear the calculator first. I need the second function here to get cos. And then we've got 24. Oh, that's a 4. 24 divided by 40. Okay, and close that bracket there. And that gives us 51 second. Am I in the right? Yeah. 53.13 degrees. Okay, right, let's check that that is correct. Yeah. Okay, right, let's have a look. 1 second. No, that was in degrees, that's fine. Okay, so let's get the answers to this section here. So there we go. We've got, the first one was right, 1000x. They've written it as y over 10,000, which is fine. You could write that. You can also see that was acceptable there as 0.001y. Yeah, there we go. So all of those things were fine. And then here, what we've got is we've got sine must be less than 1, or their opposite is greater than the hypotenuse. So we went with option B here. We said that the hypotenuse had to be the longest line, and so that doesn't work. And then they've given us 53.1, yeah, which is what we did, 53.13. Okay, great. So there we go. Right. Let's have a look at question 22. On a bus route, there is a set of traffic lights and a level crossing. The probability that the bus stops at the traffic lights is 0.7. The probability that the bus stops at the level crossing is 0.2. Use the information to complete the diagram. Okay, so traffic lights, 0.7, they've put that in. So the branches of a probability tree add up to 1. So we've got that there. And so now let's look for the level crossing. So the probability that it stops is 0.2. So that means this is 0.8, 0.2, 0.8. The way we work out the probabilities with, 1 second, stops does not stop. Oh my gosh, stop, stops, doesn't stop. Okay, that's that completed. Now let's have a look at part B. Part B says, find the probability that the bus stops at either the traffic lights or at the level crossing, but not both. Okay, right, so what we want here, let's highlight the routes that we need. So it wants us to either stop, then not stop, or not stop, then stop. Okay, so it wants one of these two things. So the way we use a probability tree diagram to find out the event is we multiply along the route. So the probability that it stops, then doesn't stop, is 0.7 times 0.8. And the probability that it doesn't stop and then stops is 0.3 times 0.2. Now, once we've done these, we can add these together because the options of different routes increases the probability. Okay, so let's get out the calculator and work these out. Let's just make this a basic calculator again. So here we go. We've got 0.7 times 0.8. So this bit gives us 0.56. And then 0.3 times 0.2. Let's see what that gives us. 0.3 times 0.2 is 0.06. Okay, here we go. We've got those two bits now. And now we just need to add those together. So we've got 0.56, add 0.06, and see what this gives. So 0.06, add 0.56, and that will equal 0.62. Okay, there we go. And that's the answer to that. So let's just check that with our mark scheme. Yeah, 0.62 there. And that means that this bit has to be correct because we wouldn't have got the right answer if it hadn't been. Okay, right, let's have a look at question 23. So, right, question 23 says, the measurements in centimetres of two triangles are shown in the table. Are the two triangles mathematically similar? Show how you decide. Okay, right, so let's just draw two triangles to try and... I'm just going to match them up, side 1, side 2, side 3. Okay, so they are in order. So here we go, let's go. Side 1 is the shortest. So we've got 2.5 versus 7. Then we've got 3.2, which is a bit longer than that. Let's go here. 3.2. And then this one is 8.96. And then lastly, we've got this one, which is 4. And this one, which is 11.2. If they are mathematically similar, this should be a perfect enlargement of this, which means that whatever I times 2.5 by to get to 7 will be the same as what I times 3.2 by to get to 8.96, and the same as what I times 4 by to get to 11.2. So what I need to do is, I've got to think about 2.5 times something equals 7. So I'm going to do 7 divided by 2.5 to find out what that is. Okay, so here we go. Let's pull out the calculator. So what we have here is 7 divided by 2.5, and this equals 2.8. Okay, so this one is times by 2.8. Now let's try the 3.2 to the 8.96. So 3.2 times something equals 8.96. So let's do 8.96 divided by 3.2 and see what that gets. 8.96 divided by 3.2 equals 2.8. Oh, well, yeah, that one's right then. Times 2.8 is looking promising. And so now let's try the 11.2. So 4, well, actually, let's just test it out. 4 times 2.8, let's see what it gives. So 2.8 times 4 equals 11.2. Excellent, yep. So they are mathematically similar because one is a direct enlargement of the other with a scale factor. So yes, all lines enlarged with scale factor of 1 second, let me move the calculator, sorry about that. So here we go. Yes, all lines have been enlarged with a scale factor of 2.8. Okay, so there we go. Right, let's have a look at B. So B says, are these two triangles definitely congruent? Give a reason. Okay, right, so congruent means that they're exactly the same, okay? So these are not definitely congruent because we do not know the size of any of the lines, okay? So we don't know that they're exactly the same size. No, because we do not know the size of the lines. Okay, right, let's double check with the mark scheme that that's all correct. So here we go. Yeah, there we go. The ratio's the same. Yes, all the lengths are the same. 3 correct comparable ratios. Okay, yeah, all very well and good. We got 2.8 there, so that's fine. Part B, no, length of sides not known. Okay, right. Let's have a look at this next question here. We'll get on to page 20 of 24, so hopefully not too many left. Right, so this question here says 2 kilograms of carrots and 5 kilograms of potatoes cost £6.36. 3 kilograms of carrots and 2 kilograms of potatoes cost £5.25. Find the cost of 1 kilogram of carrots and 1 kilogram of potatoes. Okay, so these are simultaneous equations, and in order to solve these, what we need to do is we need to make either the quantity of carrots the same in both equations, or the quantities of potatoes the same in both equations. So what I'm going to do is, in order to achieve that, I'm going to go for carrots first. So if I multiply all of these values by 3, and I multiply all of these values by 2, what I'll get is I'll get 2 equations with the same number of carrots, different number of potatoes, different prices, but I will be able to then combine that information with the other one to work out the cost of that amount of carrots. So if I've got here, so this top one is going to give me 3 kilograms of carrots, 6 kilograms of carrots even, plus 15 kilograms of potatoes is going to equal 3 lots of £6.36. Let's bring up the calculator for that. So here we go. 3 times 6.36. 3 times £6.36. And that's going to be £19.08. Then what I've got here is I've got 6 carrots again, plus 10 kilograms of potatoes, and that will equal 2 lots of £5.25, which I know is going to be £10.50. So here we go. What we can do now is we can remove this second equation from the top one to find out how much the 5 potatoes cost. So 5 potatoes is going to equal £19.08. Take away the £10.50. So there we go, £8.58. Okay, so 5 potatoes cost £8.58, so we can work out 1 kilogram of potato. Okay, so by dividing this by 5. So that's going to be 1 kilogram of potato equals £1.716. Okay, right. Now we know the cost of 1 kilogram of potato, we can find out how much the carrots are going to be. So let's use this equation here. So we've got 2 kg of carrots, so 2c, plus 5 kilograms of potato. I can actually just use this price here because that is 5 kilograms of potato. This isn't right. Something's gone wrong. Why isn't that going to work? Because it can't be that 2 kilograms of carrots and 5 kilograms of potatoes cost more than... It can't be that the 5 kilograms of potatoes cost more than the combined cost of the carrots and the potatoes. So something has gone wrong in my working out. Where have I slipped up? That is very confusing. Right, 1 second. I'm going to need to start again with this because I don't know where I've gone wrong, and I'll never get it back. So let's do this again and see where we go. Okay. So what we've got first of all is we've got 2 kilograms of carrots plus the 5 kg of potatoes equals £6.36. Then what we've got underneath that, we've got 3 kilograms of carrots plus 2 kilograms of potatoes is equal to £5.25. Okay, so I'm going to multiply this equation by 3. I'm going to multiply this one by 2. Okay, so This gives me on the top 6 carrots plus 15 kilograms of potatoes equals, one second, let me just change those to peas. Okay, and then we've got £3.36 times 3. Okay, so £6.36 times 3. So that was right, 1908. And I know where I've gone wrong. This is 6 carrots. I put a 10 here instead of a 2. I should have put 4p here, because 2p times 2 is 4. And then that is £10.50 again. And then what that tells me this time, when I take these away from each other, I'm left with 11 kilograms of potatoes this time. And then I've got to do that 1908, take away the £10.50 again. And that gives me £8.58. Divide that by 11 to find 1 kilogram of potatoes. And that's 78 pence. So 1 kilogram of potatoes is 0.78 pounds. Okay, so now I can use this. Feature in here. So I'm going to replace the cost of potatoes here. So I know that 3 times the cost of carrots plus 2 times the cost of potatoes. So I'm going to times this by 2 plus £1.56 equals £5.25. So then I need to work out what plus £1.56 equals £5.25. So let me just move the calculator over here. So I'm going to do £5.25, take away £1.56, and that leaves me with £3.69. So I know that the 3 kilograms of carrots cost £3.69. Divide this by 3 and I get 1 kilogram of carrots. And then 1 kilogram of carrots equals £1.23. And then we can write this in our answer. So £1.23, oh that's an 8, £1.23 and £0.78. Okay, right, let's move on to the last question. Okay, one second, just take a look at that and I will be right back. Okay, right. So let's have a look at this last question here. Well, actually, let's just check the answer to that last one first. So here we go, £1.23 and £0.78. Great. Okay, right, let's have a look at question 25, and then we'll see how we get on with this one. So, Riley and Sam are conducting surveys. They are both given the same list of 12,463 people from which to select their sample. Riley selects the 56th person. Sam selects the 64th person. They both start counting from the first name in the list. Work out how many people will be selected in both surveys. You must show your working. What does this mean? Right. So Riley and Sam are conducting surveys. They are both given the same list of 12,463 people from which to select their sample. Okay. Riley selects every 56th person. Sam selects every 64th person. They both start counting from the first name in the list. Work out how many people will be selected in both surveys. Oh, goodness me. Right. So let's have a look at this. So Riley selects every 56th person, but she selects the first person first. So she's got the first person. Okay. So she's got person number 1. And then she's got person, well, it's going to actually be person 57 next, isn't it? Because every 56th person will mean that if this is person 1, if that's person 1 to 56, the next person she'll select will be the 57th. Okay, and then we've got here that then she's going to get the next person as well, which will be 56 people on from then. So 57 add 56. So the 113th person. Okay. So this is a sequence. Okay, I think this is what we've got to realise here. So do you know about the nth term? Okay, that's the question that we're thinking about here. Do we know about the nth term? So I'll add 56 to this again, just to get a few terms here. Then we've got the 1/69th person here. So this is a sequence, and it's going to be like this. It's going to be n, it's going to be 56n minus 55. Okay, so this is the nth term for this sequence here of people that Riley is selecting. Okay, so the sequence, this is the formula here that we're going to do. And so what we need to do is we need to work out how many people appear in the list for this being the nth term. Okay, so the reason why this is the nth term is because if n is 1, 56 times 1 gives us 56, and then 56 minus 55 gives us the first term, gives us 1. Okay, if n is 2, we'd have 2 times 56, take away 55, which would give us 57. So what we want to work out is how many terms exist within 12,463. So what I'm going to do is I'm going to solve this here. So 56n minus 55 equals 12,463. Okay, so let's add the 55 to both sides equals this here. So 12,463 add 55 is going to be 12,518. And now what I want to do is I want to divide this by 56. Here we go. So n equals 223.5. Now, because this is a list of people, this means that the last person that will be selected will mean that Riley is going to select 223 people. Okay, so Riley is going to select 223 people. Now let's look at Sam. So Sam's got the 64th person. So we've got person 1, and then we're going to have person 65, and then we're going to have person 129. Okay, we're going to then, remember this is a sequence again. We're going to have the next person, which will be, add 64 to that, so that's 33, 193. So we're adding each of these people on again. So this again is a sequence, and it's an nth term. So let's work out the nth term of this sequence. So the nth term of this sequence, well, we know it's going up in 64s, so it's 64n. And then we need the first term to be 1, so we have to take away 63. Now what we want to do is we want to find out how many terms there will be within the total of the 12,518 people. Okay, so here we go. We've got this equation to solve, and this will tell us how many terms there are inside this sequence, inside this number of people. So 64n, take away 63, we can do 64n equals 12,518, add the 63. Okay, so that's 12581. And then if we divide this by 64, divide 64, we'll get 196.57. So that means that there's 196 terms, 196 people in the list when you're counting every 64th person. Okay, so we've got here then, we've got 223 people from Sam. we've got 190, one second, what was it, 194? 196 people from Riley. Okay, work out how many people that will be selected in both surveys, okay? So we've got to then just add these together. So if we add them together like this, okay, so if we add these two values together, here we go, 223, add 196, equals 419. Okay, so in theory, they'll select 419 people across the two surveys. I'm a little bit nervous about this question. It was quite out there as questions go. So let me just move that. Let's check with the mark scheme to see if they agree. Oh, they don't agree at all. They've said 27 with the correct working. So that is completely out of what I've done. So I have probably made up a question because I haven't read it correctly. Let me have another look at this question. I am really sorry that happened. Let's wipe out all of this information. I did not read the question correctly. Okay, so here we go. Let's get rid of this, and start again. I'm very sorry for wasting your time. Ah, I get it. It's not how many people will be selected in both. Right, I've got it. What they mean is this is a lowest common multiple question. So they want to know that if I'm selecting every 56th person and I'm selecting every 64th person, how long before the same person is selected twice? And how many of these people that are being selected twice will be selected out of the 12,463 people? Okay, right. So if you picture it, so they're both, yeah, okay, fine. So we need to know how many common multiples they have within this. So, right, what we're going to do here is we're going to break this down into prime factor decomposition. So we're trying to find out, basically we're finding out the lowest common multiple, find LCM, and then we're finding how many times that exists within this, okay? So find the LCM first. So let's do 56 is going to be 2, and 28 is going to be 2, and 14 is going to be 2 and 7. Okay, so that's 56. 64 is going to be 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay, right, so now we've done that, what we can do is if we think about 56 equals 2 times 2 times 2 times 7, we think about 64 equals 2 times 2 times 2 times 2 times 1, 2, 3, 4, 2 times 2. Okay, what can we get out of both of them? So this is common to both. So this is what needs to exist in the lowest common multiple. So LCM, so it's first of all equal to this, which is 2 times 2 times 2, which is 8. And then in order to include the 56, we need to times it by 7. And then in order to include the 64, we need to times it by these 3, which is 8 again. So the lowest common multiple is 8 times 7 times 8. Let's work that out. 8 times 7 times 8. Okay, here we go. So 4, 4, 8. So every 448th person is going to be selected by both of them. Okay, so every 448th person is going to be selected by both of them. So that's going to be the first person, and then that's going to be the 449th person, and then that's going to be, add on another 448. So 1 add 448 equals this. Add another 448 will be this, 8, 9, 7th. And then basically what we're going to do is we're going to do what we did before. So we get the nth term again. So basically the nth term is 448n minus 447. Okay, and then we say that that equals the 12,000. The 12,463 people. 12,463. Add the 447 onto both sides. So 12,463. Add the 447. Equals this. So 448n will equal 12,910. Divide it by the 448. Divide it by the 448. And I've got it wrong again. Interesting. Where have I gone wrong? Right, because they've said 27. Right. So they've just divided it straight by 448. Okay, maybe that's what we want to do. How many lots of 448 fit into it? So I've overcomplicated it with the sequence thing. Okay. So we want to know how. Yeah, that's fair. Okay. Sorry about this. Right. So we know that So we want to know how many lots of I've overcomplicated it. How many lots of 448 fit into this? So what we've got. So we have 448 times what equals 12,463. So we do 12,463 divided by 448 and get what this equals here. So there we go. 12,463 divided by 448 is 27.8, which will be 27 people. Right, I'm very sorry about that. Goodness me, that's very embarrassing. 27 people. Right, okay. Let's have a look at this question 26 and go from here. So here we go, we've got question 26, and this says XOY is a sector of a circle with centre 0, with centre O even. Show that the area of the sector is 15.3 centimetres squared, correct to 3 significant figures. Okay, so the area of a circle is given by pi r squared. The radius of this circle is 5. So the radius of this circle is going to be, if this was a whole circle, if you imagine it like that, the area of the whole circle would be pi times 5 squared. But we've only got a fraction of a circle. So remember, this is 70 out of the whole circle. The whole circle would be 360. So this is 70 out of 360 multiplied by pi times 5 squared. Okay, so here we go. We've got 70 divided by 360 equals this, and then multiply this by, I need to switch to scientific here in order to get the thing. So 1 second, I just did all of that off screen. So here we go. We've got 70 divided by 360 equals this, and then we multiply this by pi times 5 squared. Okay, there we go. So that is 15.27. And then they want it to 3 significant figures, which means 3 digits. Okay, so it's this bit here, but this is going to go to 15.3. Here we go. Oh, and therefore we've proved it. We've proved what they've asked. Okay, great. We don't need to check that because the proof is already there. They've given us the answer in the question. Right, that is it. Okay, I'm done. That is the end of the paper. Where is the bit that says end of paper? There we go. Right, excellent work. Thank you so much for sticking with me through that. Now, I did say at the end I was going to go through any questions that anyone had. So if anyone wants me to revisit a topic or do a little bit more, let me know. I will hang on about for a couple of minutes and then I will leave. Okay, cool. Thank you. Okay, perfect. Well, thank you very much, and see you soon. Oh, 1 second. Oh, thank you very much. Yeah, I'm hoping to do paper 2 and paper 3 on Thursday and Friday. So I'll try and schedule the live lessons so that you can know when they are. But that is my plan, to do them Thursday and Friday, probably in the morning at some point. But yes. Thank you so much for joining, and yeah, hopefully see you then. Okay, and sorry about that last question again. I must apologise. But right, okay, cool. See you all soon. Bye.